Good morning, everyone. So I probably need to amp up a little bit. Good morning, everyone. This is the most tough session when you want to go ahead, step out for a tea. So I'll probably try to make it more interactive, and I'll keep it light. About 20 minutes, but I wanted to start off with the presentation. It's a very interesting topic, something that the key message from here is what are we trying to accomplish and why do we need to accomplish this, right? So with that in mind, is there a ticker? Thank you. Okay, thanks. So this is me. I work for GlobalLogic. I head the technology sector for Asia Pacific. The key elements that I wanted us to think through, mull through. I mean, IT industry has been in inception for close to about 40 years from where we started off, right? In India especially, of course, we had the elements of computers before that, but the major shift probably in early 1980s and then following on. From there on, what have we done, where have we reached, right? Why and what is the relevance of intelligence and sustainable engineering? It's a very, very important topic. It covers something that we are daily consuming, and hopefully we're realizing that with the technology benefits, there's also elements that we're introducing subconsciously with or without making a contribution to some of these elements, right? What are those things? Just a fact check of where we are. Why does it matter? Because we are using 190 billion tons by 2050, which is more than doubling, almost 100 billion as of today as we speak, right? So that's massive amount of consumption. There's going to be a demand on water consumption, 40% more than where we are today, and that most of us know the most valued commodity in the future is going to be water, right? And then energy is going to increase by 50%, which is also a massive for some of the countries across the globe, which is going to struggle with the energy production and energy consumption. This is going to be quite a bit. Food production, we're going to have a 70% increase where there is already a shortage across the globe. We need to have an equality, but then in reality, we don't. So therefore, consuming another 70% more is going to be quite, tough to digest, literally, figuratively. And greenhouse gas emissions. If you look at it, we're going to increase it by 50% from where today, and that's an unsustainable element of consumption, or why we need to address some things which are very, very critical. Of course, this is a very big problem statement that we are throwing out, but the reality is that how are we able to micro slice this and see how we can help from an information technology sector is something that we will discuss today, right? So we term this as intelligent, and I just added a sustainable word to it. Intelligent plus sustenance engineering is what we are trying to do at GlobalLogic, which is part of the Hitachi ecosystem, right? So with that in mind, if you look at our consumption as we speak today, right? Digital technology is responsible for 4% greenhouse gas emissions, and we are going to increase it by 8% in a matter of a year. So that we are doubling it, and that's one factor. And digital technology energy consumption increased by 70% between 2013 to 2020, which is again another massive scale out in terms of consumption. And the world's collective digital carbon footprint is 3.7%, which is equivalent to the airline industry, which throws about 4% of carbon emissions. So we are actually competing with airline industry to be the worst culprit. So this is something that I wanted us to digest, that this is where the industry is headed. There are problems, there are things that we are subconsciously introducing into the ecosystem, but also something that we should consciously see how we can overcome this or we mitigate some of these things, right? So one of the big drivers for Hitachi is what we call as Hitachi social innovation. We are a very, very socially conscious organizations. We are close to about 700 organizations within the Hitachi ecosystem, 696 to be in total. we are very efficient with operational technology. Hitachi has been in existence from close to 150 plus years, and that's a massive amount of technology, operational technology that we are very good at, right? We've been known for many things, including rail, including, I'm not sure how many of you know this, in India, the safety systems of Indian Railways, we are proud to be part of it, so we are happy to contribute to the well-being and social well-being of our fellow citizens. We're also into many things, including energy, including health, and including, of course, what we recently acquired 3 years ago. GlobalLogic is part of Hitachi ecosystem, which brings in the digital/intelligent transformation services, and that forms the tip of the spear for Hitachi companies, right? So with the combined synergies together, what we want to do is we want to address sustainable solutions for industries such as energy, transportation, and urban infrastructure. What we do is leveraging the data-driven insights. We wish to optimize the resource usage. We want it to be sustainable, and we want it to be where we are happy to contribute back to the society and make us a lot less reliant on the consumption of these big energy drivers. What is it that we have that we wish to project? There is what we call as intelligent solutions for complex engineering problems. In fact, we have looked at a software development lifecycle. We believe there are 3 major drivers that we have brought to bear that is very impactful. One of the things that we always have is we are always challenged towards the transitions. That is a part of life. We take over projects from our competition, from our ecosystem, whether it is within the geography, whether it's outside geography. And normally, what you'll end up is there is a huge challenge in terms of inheriting something that you have not created. So what we do is we have looked at a smart transition, which is intelligent enough. We call it intellect, a play on words. And what it does is it actually looks at the existing architecture, it looks at the design, it looks at writing a sustainable software that enables to reduce the tech debt. It also enables us to look at the documentation. It also enables us to enable our teams to be productive at the earliest given instance. So this is what we want to accomplish. The challenge that we had a particular use case where we had to take over one of the projects from an Eastern European country. The problem was anytime the transition happens, I'm not sure how many of you of us are willing to transition something that we're doing. So what we normally face is the lack of documentation, the lack of knowledge, and sometimes a little hostile transition that comes into play. And the level of documentation or level of understanding of each of the complex business systems that is requires us to look at the code, regenerate the documentation. With the power of generative AI, a lot of these are coming to bear, right? The ability to look at the existing source code, the ability to look at what is the tech debt that's got introduced, and the ability to make sure that we are able to fasten the transition process. Usually it takes anywhere between weeks to months, but we want to say how do we ensure we look at saving 40–50% of the timeline and get to the position where we are able to transition and we are able to take over, become the primary, the secondary, and then making sure the shadow works, and then we become the primary. So this is our life cycle. What we have looked at it, we have just said, how do we look at making sure that we are able to read through and then get into the level of comfort that we can start the productivity of the software at the earliest given instance. The second problem, or second use case there where we had a company that wanted to outsource the CRM, and what the implication was that they wanted it to be a modern, they wanted it to be cloud-based, but of course, given that there is already in production, they didn't want to disrupt the existing ecosystem, they didn't want to disrupt the existing client base, and of course, the SLAs don't change, right? So given the situation, what we were able to do, we were able to look at the existing code base, and we were able to modernize it, and we are able to put it into production without major disruptions, was something that we were able to accomplish. That is about the transition process. The next one, what it does is it gives us an overview of how we were able to accomplish it. we looked at how do we look at our approach, what was the outcome. In fact, both of the engagements that we had, whether it was a transition from an existing vendor partner or it was a legacy code base that we were able to successfully transition and put it to production at the earliest given instance. The clients were very happy. They were pleased with the outcome, and we have been taking them to other clients and making sure that the transition process becomes that much less risky. This is one part of it. The next one, where what we looked at is generative AI, and I'm sure most of you understand, is going to disrupt the industry. There's a lot more things that's coming up. Many things are in infancy, but then reality is what it does is we had an issue with the quality assurance process. Anytime you do the automation, most of you are aware that if you can get to 50-60% of the automation accuracy, then it will be a very good return on investment. Unfortunately, very few engagements get into that amount of automation. And at the same time, you're also looking at the constant change in the business requirements. This is a day in the life of our software, right? Every time you develop something, you start off a requirement solicitation, you get into the design, you get into the architecture design, and then by the time you get into code, something would have changed. The business would want to say, I want to make sure that I add this feature before you take it to production. So what do? In this case, there's always a gap that gets introduced, whether it's the technical solution, whether it's the requirement solicitation, or the quality in terms of the quality assurance process. You have taken a particular path, now you need to make sure that you have a regression on a quality assurance strategy, right? So what we did was we looked at the exact problem in a very inverted way. So we said, why are we looking at a particular problem from a quality assurance coverage through the top-down approach? Why don't we look at, if it's an existing software, we were able to look through the code base, we were able to identify some of the most defect-inducing component of the code. Why is it introducing? So we were able to introduce 2 or 3 solutions there. One was, is it good enough to have a self-heal mechanism? Can we write a code that can fix itself based on some data elements, some validation elements? Is it okay for us to relook at the code and see if we can address it as a self-heal mechanism? The second component was, we want to make sure that where there is a defect, we prioritize that particular code base or that particular segment of the code base and see what are the type of defects that are introduced and see if we can fix it, right? Whether it is the severity 1, 2, or 3, and something that we can look at and bring down increase the code quality, bring down the defect injection ratio, thereby addressing the most problematic segment of the entire code base. The third one which we wanted to do was introduce an element of regression, where the more you automate in your regression cycle, the better the quality, the better the outcome. Normally what happens is whenever there is a change in the requirement, you would normally see that it's going to be problematic to make the coverage of the quality assurance process, and thereby looking at all these 3 holistic ways. Is there a self-heal mechanism? Is there a defect that is from a code segment that is most problematic? And also, how do we increase the regression cycle of the quality assurance process that can eliminate the defect injection ratio and address it? We've done this with 4 or 5 clients. It's given an amazing results, and we are very happy to say that the outcome of where we're looking at it from a top-down, instead of doing a top-down, we're looking at where the defect injection ratio is maximum, and we are able to address those elements, and it's given rich dividends to what we want to accomplish. This is the QA companion that I was talking about. We have the key components that we were able to address it, and leveraging GenAI framework, we've been successful in going back to our clients with an offering, and it's proven good, given good results for us. The final part, which is very important, the 3 components that I was talking about, it's about how do you look at the legacy modernization, greenifying the code, and also innovation. Why do we say this? When you look at, and I'm sure any one of us in this industry who have spent enough number of years, the biggest problem that one gets to understand is the legacy code. There will be one or two specialists. You will have to pay through the premium to get that person to give you the clarification. And then once that happens, you have to work on the person's timeline, the availability, and also how far enough the person is able to willingly share the knowledge that has already been built out. There are a number of examples in the industry, banking industry, where you have got a core banking solution. Somebody has built it in 1970s or 80s. I was aware of one of the organizations I was working for, built in Clipper and Foxbase and on mainframes. There was one person in the world who knew the entire end-to-end implementation, and you had to depend on the person for giving your clarity, and the person would come back and say, well, I'm on vacation, you can come back to me after 3 weeks. If a banking solution is down, you don't wait for 3 weeks, right? If it's business critical applications, you know that you need to relook at it. Generative AI has been a boon for such situations. What we've been able to do, we had one of our clients who had a board governance program. It was in a legacy framework, no documentation. We relooked at the code, were able to regenerate the entire documentation. We got about 65–70% in terms of the code coverage or code documentation coverage. Very good outcome. We were able to look at the exact implementation. What are the flaws? What are the things that we should look at, and how do we reduce the tech debt? Good outcome for us. That's something that we are very satisfied, comfortable with, where we are able to regenerate the documentation process. The second one, which I wanted to talk about, is in fact looking at what you have. Normally what happens is there are thousands of lines of code that are written, and there are hundreds of contributors to that line of code. What normally happens is nobody looks at whether the code is actually leveraged or is being compiled or is being used at all. So we have what we introduced as Captain Codify, this one, Captain Code Greenify. It's a term that we have regenerated, and we are happy to do that. One of the things that it does is relooks at the entire code base, eliminates those lines of code which are unutilized, or looks at the code and says, is there a better way to write this code and optimize it? One of the snippets is where you have a concatenation of one of the array items. What it does is, in a previous instance where you have the items that are being leveraged in a different format, what it normally used to take a 3x of a processing time, we've been able to reduce it to minus this one 30% in terms of the leverage of CPU. That has given us the element of how do you look at the existing code base and come up with a recommendation that can give the better outcome in terms of the way that we are actually looking at. The final, this one is, I wanted to conclude this with, can we replay the presentation, please? Can you replay the presentation? Sorry about that. So here's where you look at the different cycles across the software development. There are elements between the requirements analysis, architecture and design, development and quality assurance and deployment. And each of us know that by the time each of these phases go through, there is an element of gaps that gets introduced, whether it's the requirements capturing, whether it's the architecture, or whether it's the code issues. Eventually, there is an element of lag, there is an element of gaps that gets introduced. What we've been able to do, we've been able to successfully look at the entire software development lifecycle. We've been able to address those which are in green. We've already leveraged the Gen AI framework. We call this as Velocity.AI. We're introducing Velocity into the existing ecosystem. Those that are in the works, that's highlighted in the yellow, and the ones which are in red are actually to be planned. So looking at the entire life cycle of a software development, we've been able to introduce generative AI solutions, calling it Velocity.AI, and we've been able to fast track some of these elements and improve the throughput or the velocity. Thereby, we've been able to take it back to our clients, where we've been taking it to Hitachi ecosystem. We call it a platform of platforms, where it's a central repository of how do you procure, how do you leverage, and how do you use different environments and reduce the overhead in terms of each of these 700 companies could go and take a license on their own and start building it from ground up. What we've been able to do, we've been able to bring it all together based on a licensing and a subscription process. We've been able to spin off instances where the entire end-to-end life cycle of any given engagement is optimized and is leveraged and is also reused for its fit for purpose. So with this, a lot of wastage, a lot of introduction of resourcing that we would consume, we've been able to save it. We will come back with the numbers because this is something that we have gone into a trial period. We'll be able to come back and present the numbers that we've been able to save and share it very soon. But early results tell us that we've been able to do about 20 to 25% of life cycle savings in terms of how we are able to bring in not only less resources, but also consume less licenses and thereby spinning off the instances. So finally, this is the entire Velocity.AI. We have got it given from Generative AI. It's a human-guided, but leveraging the Generative AI right from the resource requirements capturing to infrastructure to the design, and in fact, how do we consume it, how do we operate it, and how do we deploy it, thereby leveraging it and then making sure that we are optimal in our resource consumption. So finally, this is my last ask from all of us. It's a very important ask. The reality is that when we are looking at a sustainable engineering, we have powerful tools and innovative technologies that gives us positive change. It's been an amazing journey so far, right? But the realities are, it's also, the tooling is not just enough. What really matters is our collective intent and responsibility. So adopting new technologies, and it's about getting a culture that is sustainable in every decision, in every design, and in every action, which is most important that we need to take. And as we embrace these solutions, we should remember that sustainability is a shared mission, one that transcends boundaries and requires participation for all of the stakeholders in the ecosystem. Together, we can create a future that balances progress with preservation. The greatest threat, which is most important, is that our planet there's a belief that someone else will do it, and I don't need to worry about it. So with that message, I thank you for your time, and it's been a wonderful journey for us so far. We'd love to have more interactions.